do a bit of housekeeping. So welcome to the Azure Cloud Commanders Learning Room. We're going to host Richard today, which is really good, some great content. So this session is being recorded just on behalf of the Learning Room. So if you do not consent to be recorded, please disconnect your line. This upload, the recording will make it to YouTube for those who haven't been able to watch it today. But your attendee names are hidden, but if you come off mute or are mentioned in any way, just be aware of that. We're in learning community, so everyone's coming at this from very different landscapes. You could only hear of cloud technologies today, or you could have been working in the field for 5 years plus. So just be aware that everyone's coming from different backgrounds, different diversities. No question is a stupid question. Everyone approaches it differently, just being nice. Raise hand if you want to ask a question, mention it in chat, unless the speaker mentions otherwise. And yeah, just have fun and learn. So my name is Luke Murray and I run the Azure Cloud Commanders Learning Room, which is hosting the session today. So welcome, just from New Zealand. And you're not here to listen to me speak. So we've also got Richard as well. Let Richard sort of speak a lot more towards his background. But yeah, very cloud native, very knowledgeable in this space. So it's a privilege to have him join us for this session. So Richard, yeah, take it away. Thank you for joining.
Yeah, thanks for having me. So yeah, Richard Hooper, as Luke said, also known as Pixel Robots Online. So check me out, Google Pixel Robots. You'll find my blog, YouTube, and everything like that. That picture there is from my wedding. It's the best one I could find for online purposes, so I use it on LinkedIn. Yeah, that's pretty much me in a nutshell. LinkedIn, everywhere you can find me. Always happy to chat, so just feel free to ever reach out if you ever have any questions that we don't cover today or anything in the future. And with that, I think I'm going to share my screen and just get straight to it. And what I'm going to do is share the Azure portal to start off with. So I don't like slides because I always found death by PowerPoint and stuff like that. So let's just get straight into it. So obviously we're in the Azure portal. I'm in my own Azure portal here. It's just like my MVP subscription. And we're going to talk about Kubernetes. As you can see, Kubernetes is my first resource because I always use it. So if you don't have that at the top, you can always click on the top here and search for Azure Kubernetes. And then it will come up as here, Kubernetes services. If you just type in, say, let's just give it all this and do AKS, which is the name for it. If I can type correctly, you'll see Kubernetes Fleet Manager come up and some other bits and pieces come up. But we don't need to worry about any of those. We just care about Kubernetes services. But Fleet Manager, if you are worried, is a way to manage multiple AKS clusters using this fleet, which is like an AKS cluster up in the cloud managed by Microsoft, and you can do loads of updates with it or distribute your workloads over different clusters. Bit too advanced for this session, but just be aware it's there. So we'll click on Kubernetes services. I can see I've got 2 clusters already here. These are just some of my test ones, but we're going to ignore those. And what we're going to do is click on the create button at the top, and then we get 3 options: create a Kubernetes cluster, add a Kubernetes cluster with Azure Arc, or create a Kubernetes cluster with Azure Arc. So these clusters here, these Arc ones, are any cloud native certified Kubernetes clusters which you can add into Azure so you can manage it via Azure. So think about policies, governance. So these can be on-prem, different clouds, maybe Raspberry Pis. I think that's supported now with the ARM-based processors. It never used to be, but I think they've released that now. But we just care about the create a Kubernetes cluster. So we're going to click on that one. And then we get this nice Azure portal welcome list. Click next, 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 finish. But we're not going to click next, next, finish. We're going to walk through it. So obviously, yeah, select your subscription name, create your resource group name. You can create one here, or you can use an existing one. Obviously, I've got loads, but I'm going to leave it blank for the moment because there's a cool little trick it can do. Then we have these cluster preset configurations. It's a drop-down box with production standard, dev test, production economy, and production enterprise. Very short descriptions, but we can click on the compare presets, and then we get a nice little table. So production standard gives us a system node pool of a D8 DSP5, so nice beefy machine for that. And it can do auto scaling from 2 to 5. And then it gives us a workload user node pool of the same size by the looks of it. We'll go into the difference between the system and the user pool shortly, but just be aware there are two different ones. It then does availability zones like you'll get with virtual machines and other resources. Azure policy can be enabled, Azure monitor. This thing called a secret store CSI driver. So CSI driver stands for container storage interface. It's just a way to inject things into containers at a certain point, be it secrets, volumes, Azure disk, Azure files, that kind of stuff. Then you pick your network configuration, so Azure CNI, so that's Azure Container Network Interface. And then if you want network policies, which is like your firewall rules, your NSG rules, but inside Kubernetes, so it stops it from leaving the cluster. And then some authentication methods, so local accounts with Kubernetes RBAC, so rule-based access control managed inside Kubernetes. But then you can also do Azure role-based access control, which is a better thing to do. And then you just control your Kubernetes role-based access control from Azure rather than Kubernetes. But these are just some presets. Most of the time, most people will just pick production standard and be done with it. So we're just going to cancel out of that. And we're going to give the cluster a name. For this one, we'll just call it let's just type Azure Commander, something like that. And then what it does automatically for me is create the resource group name on that and gives that underscore group, or I could click create new and create one. For this demo, I'm just going to leave it as that. Try and use your best practice naming standards if you can. Then we have the region. So I'm based in the UK, so I'm going to pick UK South, but every region is basically supported with AKS. It's probably one of the most supported products out there, apart from obviously virtual machines. Yeah, and then obviously if your region supports availability zones, you can pick all three. What this does is puts the virtual machines underneath, so your system pool or your user workload node pool over the 3 different availability zones. So for best practices, for production workloads, if your workload that you're running on Kubernetes can do that, use availability zones. It'll give you a better SLA at one point. Talking of SLA, we have the AKS pricing tier, and we have standard, free, or premium. So free is perfect for dev test. It doesn't cost you anything. You don't get no financially backed SLA with it though, so that's something to be aware of. And it's designed for clusters with fewer than 10 nodes, so perfect for dev testing purposes. Then we have the standard one. That's about $70 a month, which isn't actually too bad because it gives you the financially backed SLA. If you're not using availability zones, you get 99.95%. And if you are, if you're not using it, you get 99.9. If you are, you get 99.95. So it's not like the, what is it, 99s or whatever it is that you really want, but that's virtual machines for you. Nothing much you can do about that. But you can have a cluster up to 5,000 nodes. So that's a massive, like, I've never seen a cluster that big. I hear OpenAI runs on it and probably has got a cluster that big or bigger. And then premium is for if you aren't happy with doing upgrades for your AKS cluster 3 times a year. You have this long time service one, which gives you like 2 years of support for a Kubernetes version instead of the standard year. So just like adds an extra year. That is quite expensive. I think it's like 60 cents an hour or something like that. So it can add up quite a lot. So if you really, really need that, do it. But I would probably just keep to the standard one. It's probably one of my best practices. Now, out of the box, we can have automatic upgrades with AKS. This is quite new. And with the preset, it's enabled by default, and it's recommended to do patching. So this will patch your Kubernetes version. So like with Kubernetes, you have semantic patching. So semantic versioning. So it's like 1. 29.6, say. So that .6 is the patch version, and this will basically keep that up to date. What will happen though is Kubernetes will update and then your pods will restart because the virtual machines underneath are being restarted. So you need to be aware of that. If your workloads can't handle restarts, disable it. For this demo, I'm just going to disable it. But before I do, you can set schedule. So like, every week on a Sunday, first of every month, first Sunday of every month, or a custom one or no schedule. And that's for the sort of cluster. And then you have the node security patches. So like when you think of virtual machines, you have Patch Tuesday on Windows, and you have to make sure you keep that security up to date. Same principle goes for AKS. You have to keep those patched as well. Microsoft will release a Linux node image once a week, roughly, give or take, and a Windows one about once a month. So keep that in mind as well if you're going to go down the Kubernetes route. But for the demo, I'm just going to pick none, but you can have unmanaged or node image. The node image automatically will update those node images for you, restart your cluster. Unmanaged uses the Linux Ubuntu built-in patching system. So any security updates will get installed to the cluster at night, but it won't reboot the nodes for you. But for this demo, I'm just going to click none. And again, you get the schedule with that. Then we talk about that authorization and authentication. Again, I mentioned local accounts with Kubernetes. So these are the local accounts inside the Kubernetes cluster, and you're using Kubernetes role-based access control. Not a best practice. Microsoft Entra ID authentication with Kubernetes RBAC is okay. You're using your Azure AD or Entra ID, as it's called now, username, so you can get MFA to log into the cluster and stuff like that. But what I prefer is the Microsoft Entra ID authentication with Azure RBAC, because then I can manage all of my role-based access control for the cluster and the namespace from Azure. And so if like a user left the business and I disable the account in Azure, that means they're disabled in the cluster as well. If I used Kubernetes RBAC, then I have to log into the cluster to remove that user as well. Otherwise, they're already in there. So something to keep aware of. But yeah, I always recommend doing this unless you have a specific need to not. And then we look at node pools. So node pools are basically virtual machine scale sets underneath the hood, just a standard Azure resource. And with Kubernetes, you have to always have what they call a system node pool. The system node pool is running things like core DNS to handle all the internal DNS inside the cluster. So think of like your Active Directory DNS, that lives on your Active Directory server. Core DNS lives inside your Kubernetes cluster. It has a metric server to capture all of the metrics, so like your pods, metrics, CPU, memory, network metrics, and stuff like that, and a few other bits and pieces that are needed for Kubernetes to run. Now, a lot of people hear AKS as a free resource. The control plane is managed by Microsoft, so the system node pool is slightly different to this control plane. When I hear control plane, or when I first started learning about Kubernetes and the control plane, all of these pods that are now on the system node pool would be running on the control plane. But Microsoft wants that latency super close to your workload, because these control planes could be running in any data center. They try and get it. I don't exactly know how it works behind the scenes, but it's you never see it. It's all managed by Microsoft, so you can't have these services running on these control planes when you need it to be close to your workload. So you need a system node pool. This system node pool has to be Linux. At the moment, it's Ubuntu here, and it's over the free availability zones. And we have a maximum pods of 110. So each pod will get an IP inside the cluster, and you can set this number. If you use Azure CLI, this number will be 30. If you use Portal, it's 110, but it can go up to a maximum of 250 pods per node. So usually 110 is fine for most people's needs. If we click on it, it's called agent pool by default, but we can change that name. As you can see, it can only be a system pool because you have to have that system pool on the cluster. We can pick Azure Linux, which is CBL Mariner behind the scenes, but it's now called Azure Linux, or Ubuntu, but we can't select the Windows ones. We can pick all the free zones, or we can pick one zone. Always better to use free if you can. And then it's got the virtual machine size here, 8 CPUs, 32 GB memory. It will automatically auto-scale when, say, your core DNS pod hits a certain threshold of the CPU and memory. It needs to add a new core DNS pod. If there's not enough space on these nodes, it will add a new node automatically in the VMSS for you, which is really cool. And yeah, so that's automatically set to 2 to 5. They recommend you probably leave it at that. Maximum pods we can change. We can even put a public IP address on these nodes. I wouldn't recommend doing that unless you really, really needed to. You can label them. So labels are like your tags for Azure resources, but they're tags, labels inside Kubernetes. So you could say, label this node as a workload type, or like a node type, then system. So you can just do things like that. And then taints are a cool feature. So we have taints and tolerations. Taints live on the nodes, tolerations live on the pods. So you taint the node. So this is tainting the system node pool with critical add-ons only, which means Microsoft system node pool only. Don't let my workload run. If it's true, so if the pod has that inside its manifest, that key, then don't schedule it on these nodes. So the tolerations in the pod manifest say, I can tolerate any node that has this taint, so I'm okay to run on it. But yeah, this is good for the basics and leave it at that. So I cancel that. Next, we have the user node pool or your workload node pool. This is where you store all of your apps you're actually going to run. Again, it looks exactly like the other screen, except now we can pick Windows and Linux because we're set to user. The free zones, everything's the same. No taints or tolerations on this one because it can be anything. If we picked a Windows one, you can put a toleration on to say OS equals Windows, then it will run. Otherwise, you might get an issue where you're trying to get a Linux pod running on a Windows workload, which just wouldn't happen. I'll just cancel out that. Then we have this thing called virtual nodes, and virtual nodes uses Azure Container Instances to give you not quicker scaling, but per second billing scaling. So if you have a batch load of workloads, you could use that and it will use Azure Container Instances to run it inside the cluster, and there'll be a virtual node pool. Then we just have node pool OS disk encryption. You can bring your own key, or same as every other Azure service. Then we have the networking. So this is a bit fun. You can have what's called a private cluster, which means it's all like, what's it called? Private endpointed for the API. So the control plane is private endpointed into your network. There's a new thing coming out soon, which will be GA, hopefully some point this year. It's been a long time, called VNet integration. So then the API is sat behind an internal load balancer, so you don't need private endpoint. And that'll be the better way to go. Use private clusters if you really need to. It complicates it a lot. So the recommendation is to go with a public one and lock down the access to the API server using IP addresses. It's a lot easier. Then we have public access. So you can set the authorized IP here. So we could put an IP address of your office, your VPN, or something like that. Or you can leave it open. You know, you've got MFA. Not the best, but it's all right. Then we have two different network types for the Azure portal. KubeNet, which is very, very basic networking. It's good for dev test. Probably should never use it ever in production. And then you have Azure CNI, which is the Azure Container Network. And this will basically, if you're using it in the portal, every pod you run on the node gets an IP address when you allocate it. So like if my system pool had 2 nodes and I have 110 pods per node, my network range needs to be able to accommodate 110 pods per node plus 1 for the node. So that's 111 IPs per node. If I have 2, that's 222 IPs I need in that subnet. So a /24 is cutting it very, very fine. Means I won't be able to add a new node. So you need to make sure that IP range is considered before you build it. But for now, we're just going to leave it basic and let Azure deal with it all itself. You could always bring your own and then create a new one at like /16 is what they're doing by default. and you can do some DNS name prefixes, but we're just going to let Azure deal with this for our demo. Then we have the network policies. So you have Calico, which is an open source provider. You have Azure, or you can have none. If you're doing it through CLI or Bicep, you can also do Cilium, which is a different open source provider. Most people will go with the Azure one or none, and you can add them and change them at any time, so it's fine. Then load balancer is standard. They could probably get rid of this. This is here because you used to be able to use basic load balancers, but you can't anymore. I think basic load balancers have even been deprecated now, maybe. I can't remember. And then we have integration. So this is like ways to integrate it with other Azure services. So Microsoft Defender for Cloud, I have it enabled on my whole subscription, so that's automatically done, or I could tick a box here and it will do that for me. Next up is container registers. So I have a few container registers already, but what I'm going to do for this demo is create a new one and then fill in the name, and we'll just call this AKS demo UK South and see if that's available, which it is. And then I'm just going to put in the same resource group, UK South, disable the admin and set the standard SKU. I can have basic or premium. For the demo, I'm just going to use standard. If I wanted availability zones, I'm going to have to go premium, but that costs quite a bit of money. So I just click OK on that, and that will go off and create it for me in the background once I click review and create. At the moment, basically all I'm doing is building an ARM template behind the scenes, answering a load of questions to fill it all in. Next up, we have Service Mesh, and we have the Istio one, which is again another open source project from the Cloud Native community. This is a way to string things together, bring circuit breaking technology and stuff way out of scope of this. You only probably ever want to use a Service Mesh if you really need to, because it brings so much complexity to it. So yeah, leave that off. And then Azure policy, enable or disable. I always enable it, even if you're not going to use it. It's better to have it there ready to go just in case. Then we have monitoring. So there's a few options here. We have Container Insights, which is a way to get your logs from your containers into log analytics workspaces. This is going to use one of my log analytics workspaces there. And then you can set different presets, standard, cost optimized, syslog or none. And these can set the different collection frequencies and like exclude namespaces and stuff like that. So for this, I'm just going to not use it for the demo because it can take a bit of time. But we also have this thing called Manage Prometheus, and Prometheus is another open source tool from the Cloud Native community. And this is a place to sort of not collect your metrics, but query against your metrics. So think of your log analytics workspace. With the Managed Prometheus, you have Azure Monitor workspaces instead. And then instead of your KQL to query it, you use Prometheus or POMQL to query it instead. And yeah, so that will just create me an Azure Monitor workspace and configure the cluster to do it. And then we have Managed Grafana, again, another open source tool. You can see here, Kubernetes really loves the open source community. AKS loves it, and they actually give back to all these projects as well, which is nice. And Grafana is basically just a tool to visualize your metrics. So you've got Azure dashboards by default, or your KQL queries can do your nice graphs. You can use Grafana, which can use both KQL, PromQL, other data sources to get all your nice graphs. And then we have alerts, and these are just some basic alerts for CPU and memory, and then you can email the alerts out. So I'm just going to untick all of these to save time. But in production scenarios, you probably want to enable all of these, maybe not the alerts, because the alerts are going more towards the Prometheus alerts rather than Azure alerts, but they get serviced through Azure alerts, so you can still use your webhooks and action groups and stuff like that. Then we have the advanced section, and this lets you enable secret store CSI, which I always think should be under integrations, but this is basically just a way to pull secrets from Azure Key Vault into your cluster, into your workloads, into your pods automatically. You can do secret rotation and stuff like that as well. So you tick box to enable it. So you could enable it. You can use compute resources. So if you don't need it, don't do it. If you do, you can use it. Sometimes your developers might query Key Vault directly instead of you injecting the secrets into the pod. And then we can just rename the infrastructure resource group to whatever you want to match your naming standards. For this demo, I'm just going to leave it as the managed container and then the standard name. Next is tags. Everyone loves tags. We should always set tags. I'm just going to click next and not set a tag. We should in production always set tags, but demos it's fine. Now it's just going to validate what I've clicked and to make sure everything's right against the recommendations and the ARM template in the background. And it's going to click create here, and that will spin off. And in a second, we should hopefully get a little link to see how it's going. Here we go. And this is basically running that ARM template. So you can see the template is massive ARM template, and it's all because we put some inputs from the Azure portal with what we want. And that's going to go off and do it. First off, it's going to create the Azure container registry, and then it'll create the cluster. Whilst it's doing that, we're going to switch over to VS Code. Now, let me see. Friends don't let friends not use tag. So has anyone got any questions at that point? Because I know I spoke quite quick. I'm just trying to be cautious of the time. There's a lot to fit in. Nothing there. If you have anything, just
no questions yet.
Cool. Right. Okay. So Docker files is a way to build containers. So the way I think of Docker files, if you're sysadmin and you've built, you've got your exe files and you used to deploy them onto your servers and stuff like that, you had an MSI file, and then you also had like an MST file to configure it and stuff like that. So this is basically like that. We're saying we're going to use it from Nginx latest, which is a container image, which is a container image is basically just a tar file, a zip file of your system that you're going to run. So we're going to use that as a base image. We're then going to copy the nginx.conf file to the etc nginx.conf directory or file in that directory inside this image. We're then going to copy the index.html file, which I've got up here. I'll show you those in a second, to this location inside again. I'm then going to set some environment variables called background color black and the text saying hello world, obviously, hello world. And then we have a command, which is what you run when the container starts. So this is like if you have a Windows server and you needed to run a service on startup, that's basically what this is doing. So this is start in Nginx, basically copying the files over, cutting it out. This bit here starts Nginx and the daemon's off. That's all this command's doing. It's like setting your Windows service up. So when that server starts up, it runs, you're setting IIS up. You want IIS to start when that machine starts. That's all this is doing. Index HTML files, just a basic one, just some ChatGPT index file saying welcome and set the background color, and then set some text here based off of the environment variables here. And the Nginx conf is just a very basic Nginx conf to say my index file is index.html and it's listening on port 80. So what we're going to do next is build this Docker file into a container image. So if I go here, actually, let's just open up a terminal in here so we can actually make it see easier. So there's one terminal. It's under here. New terminal. And then there we go. Hopefully everyone can see that. I've even got your name, Luke. Hopefully that's about it, right? Now it's here. So we're going to do Docker build. We're using Docker commands. Then we're going to do -t for tag because we're tagging the image. So we're giving it a name, basically. Like when you're creating a zip file, you have to give it a name.zip. So here we're calling it, we're going to call it, what did I call the container registry? In fact, let's have a look because that is now finished. Let's go to resources and we'll go to the resource group and we can see the container registry here. I'll just copy that name. In fact, I'm going to copy this login server because it's got the name of the container registry.azurecr.io. And if we go back to this one, and we will paste that in there, and then we do a slice. So we're saying tag it with the container registry name, URL, and we just call this Nginx, and we'll call it v1, so : v1, You could use latest, but never use latest in production. We're just given a version number, basically version 1. And then very important bit is always put a full stop at the end, otherwise it all goes wrong. So hit enter on that. This will start building the Nginx image, and it's built that already. Nice little bit of blue text here, and it's told us it's named it what we told it. So we copied that. That copy all right. There we go. And now we need to push it up to our container registry. But before we can push it, even though we're logged into Azure, we need to log into the container registry also. So we do ACR login /n for name, and then we just need to give it the name of the container registry. Now you don't have to do the .azure.cr.io, but because I had it in the clipboard, it'll be fine. It just takes it away for me automatically, which is nice. So it just saves me hitting backspace a few times. And once that logged in, there's a survey, which I won't be taking because that's 5 minutes and you don't want to watch me do a survey. So now I'm going to get my Docker command back up. I'm going to get rid of the dot, and I'm going to get rid of the -t and the build, and I'm just going to do push and hit enter. So that's pushing the container registry. And all I've done is supplied the name, and it knows because of that slash, this is the registry, the container registry is going to push it to. It's going to create this repository inside the container registry, and the tag's going to be v1. So we'll go back to here, and we go to repositories. We can now see Nginx repository, and we can see the tag v1. And inside there, we've got the Docker pull command, so I can pull it down locally, and some metadata manifest file for the image. So that's all fine. We've pushed it now, which is awesome. So now we go back to the cluster. We can see we've got the Kubernetes cluster 128.9, Azure CNI, everything we filled in is all here. We can look at the workloads running inside the cluster. And we can see we've got the core DNS that I talked about. We've got this connectivity agent, which is used to connect to that control plane. It's like a VPN kind of thing. Gatekeeper, which is the Azure policy part. So Azure policy uses open source tools again called OPA and Gatekeeper. And these are the bits that can sort of mutate your cluster to match what your policies are saying. So these are deployments, pods, replica sets, stateful sets, daemon sets, jobs, and cron jobs. Basically, a deployment is a wrapper for your pods. And you can see here, we're saying 2 of 2. If I delete the deployment, then it's gone forever. But if I go to pods and I deleted this core DNS pod, I'll like so, because the deployment is saying it wants 2 of 2, what should happen is it will terminate it and then create me a new one automatically, because it says, yeah, well, it's already done it there. So I got it there. So it should all be fine. And then it just fixes the system. In fact, it's done at the bottom there. So it's just coming up now. Let's sort on age again. There we go. And we'll refresh that. And now it's running 23 seconds to come back. But if I delete the deployment, then it's gone forever. So if you need to restart a pod, just delete the pod, not the deployment. Replica sets are actually in between deployments and pods, and they're the bits that do most of the work to make sure there's always that amount of replicas running. Stateful sets are if you wanted to run databases inside the cluster and stuff like that. Try not to use a PaaS service first if you really need to. Daemon sets are pods that have to run on every node. So there might be ones to scrape metrics from the pod, which most of these are. There may be ones to, like these Azure files and Azure disks, to mount the disk. So they need to be mounted to a virtual machine, and that's what these do for you. Jobs and cron jobs are basically what you would expect when you're running scheduled tasks and jobs like that. So I won't go into those. Services and ingress are objects, like services are an internal IP and the internal DNS name of your pod. So here we have kubedns, and it's got an internal IP address of 10.0.0.10, and it's listed on port 53, like normal DNS would. We'll go inside it, and you can see it's connected to the 2 core DNS pods, one 2 minutes old because that's the one I deleted, and the other 6. So this is like a internal load balancer in a way between the pods, so you don't have to worry too much about that complex networking inside it, as you would do if you were looking at VMs and stuff like that. It's all done automatically for you. But with a service, you get that dependable IP address. So no matter how many times I delete these pods, the IP address of the service will not change. If I delete the service, then it's gone, it's broken. I won't be able to do DNS in this cluster anymore, and it will be terrible. Ingresses are a way to do your like reverse proxying. So if I wanted to expose a website to the internet, I could use an ingress controller like Nginx or Istio or App Gateway Ingress Controller, probably never that one, or App Gateway for containers. And what it does is create a service of type load balancer, and then I can do configurations, do SSL offloading, stuff like that. So it's kind of like a mini App Gateway inside your cluster in a way, or Nginx reverse proxy, but inside your cluster. And then there's storage. We won't go into details there, but you can do storage if you really, really need to, but probably try not to. Configuration config maps are basically configuration. It can be a JSON file inside these. It's just whatever your application needs to run for its config. Like say you had an IAS web app and you had a config map or a web.config, you could put that inside a config map and then your application can use that and query it. Secrets are similar, except they're base 64 encoded secrets. So like you can have a look here, and then you've got a certificate inside this one, and that's a certificate. It's just base 64 encoded, and it's what's needed to get the cluster to run. Let's go back into that. So you can have other different secrets, but they're not encrypted. So that's why you use this container storage, the Key Vault CSI driver or other methods. We won't go into custom resources or events because it's getting a bit too deep and we're running out of time. So now what we're going to do is go back to VS Code because we pushed our Docker container and we've seen these files, and then we're going to actually deploy the Docker file to the cluster. So we have this deployment. So we just looked at deployments in the portal. This is what a deployment looks like inside VS Code. You have the API version, so like you have to say absolutely one. If you're doing bicep or ARM templates, you have say Microsoft dot networking dot whatever, and then the date, for your API version. Then you tell it the kind. So this is a deployment. It could be a pod, it could be a replica set, it could be a stateful set, service config map, goes on and on. Then you have to give it a name, like any resource. It needs a name. Here we can set the amount of replicas. We've got 1, I could have this 2, 10, 50, whatever. Then we have these selectors, which are ways to match the resources. So this uses your labels and it matches the labels to the service. So the service knows any pod with this label is part of my service. So I will load balance over any pod that has this label, and that's how that all works. So these are very important to have the labels in there. So that's sort of the deployment spec, and then we get down to the spec of the actual container inside it, and then we give it a name, Nginx. We're going to change this name to be the one I have here, and it was a V1. So this is basically saying get the image. The image lives on this registry, and this is the name of the repository, and this is the tag version that I want you to get. We set in the Docker file that it's going to listen on port 80, or sorry, in the Nginx config that's listening on port 80. So we set port 80 here, and then we got the environment variables from the Docker file, background color, gold, and text, welcome to AKS. And here we had it black and hello world. So hopefully we'll get gold and not black. We'll find out soon. Then we have the service, and this is basically, like I said, this has to match the labels. With the selector app Nginx matches the labels app Nginx, and that's how it knows to route the traffic to that pod. So what we're doing now is do kubectl apply. So kubectl is a command line for Kubernetes, and then we need the -f in there, F for file, and then just the name of the file. Hit enter on that. In fact, what I have actually missed, see here, it says Docker desktop. I've not logged into the cluster. So what I'm going to do is Control C out of that. We'll go back to the Azure pool. To log into the cluster, super simple. We click connect on the cluster and we copy these 3 commands. If you're not in the subscription, I'm already in the subscription, so I won't copy that. So we just copy the second one here, and we'll go back to this one and paste it in. So this is AKS get-credentials. resource group, name of the cluster, and override existing. And now we can see my Docker desktop is now changed to Azure Commanders. And then because I don't want to do MFA prompting, what I'm going to do next is go here and copy this kube login, which is a new tool that Microsoft did, and it converts a kube config using the Azure CLI, so I don't have to do the MFA prompt. Otherwise, you'll watch me type in some numbers and no one wants to see that. So now, if I do kubectl get pods-a, we should see all of the pods that we've seen in the Azure portal, which we can see now. So we've got the gatekeeper, CSI, kubeproxy, metric server. That's all good. So now if we hit up again a few times and we apply our deployment, it says it's created a deployment and it's created a service. And we can see here, I didn't supply a namespace. So a namespace is like a folder inside Kubernetes where you want to put the resources. So here we've got the kube system namespace and the gatekeeper's namespace. But because I didn't specify one, where's it going to go? Well, it's going to go to the default namespace. So if we just have no -a and just do kubectl get pods, we should see we've got an image pulled back off, which means it's for some reason it's not pulled the image. Wonder if that's to do with an identity issue. It's always fun when it does that. Oh, I probably copied something wrong. I'll tell you what I didn't do. I didn't save the file. So what we can do is we just do a kubectl apply again. And what it does is you can see it's reconfigured the Nginx deployment, but it's left the service changed because nothing had changed in it, so it didn't need to reconfigure it. So now if I do kubectl get pods again, we can see that it's running, and you know what I can do again, like there's no changes. I can just do a kubectl apply, and Kubernetes it's all about that desired state. So it compares the file I've got to what's actually running. It says nothing needs to change, so it's fine, and it won't change it. If someone went into the cluster, made a change through the Azure portal or through the command line directly to the resource, and then someone ran kubectl apply again, it's going to override the changes. So keep that in mind as well. It's all about that desired state. So now if we go back to Azure and we see the workload, and then we can filter this down to default, because it's default. We got 101 and click on pods. Got that pod still running. It's been up for 60 seconds. Then we go to services and ingresses, and we can see we've got the Kubernetes service, which is just a standard one in the default one, but we've got this new one called Nginx service. And this Nginx service is the one we had in our manifest file, and we chose type load balancer. So this is using the Azure load balancer. It's given it an external IP. So if I go to that external IP, fingers crossed, I have a gold screen and it says welcome to AKS. So what we can do as well, like we can just go back to this file. We can change this to blue, save that, and then we can just do the apply again. And what will happen is it says configured and then unchanged. We go back to here, we go back to this one, and we go workloads. We hopefully see that if we go to pods, it's been up for 2 minutes, but if we refresh that, we can see a new one's come up 15 seconds and the old one is now terminating. We refresh again and it hopefully will terminate very shortly. Can take a bit of time depending on how busy it is. It should be quite quick. But what this will basically do is it does what's called a roll-in update. So it by default with no configuration, it will do the roll-in update. So it will basically spin up the new pod. If I had what's called liveness probes and readiness probes, it will make sure that pod is fully running before it starts terminating the old one. So we refresh again. The old one's now gone. This one's been up 32 minutes. Potentially, if I do it, there we go. It's gone to blue already. So that's quite nice, and that's just a sort of basic sample of showing you how to use environment variables. Kubernetes is all about that desired state configuration, and that's basically how you can spin up a Kubernetes cluster using the Azure portal, create a Docker image, push it up to container registry, configure the manifest file, the deployment manifest file, deploy it to the cluster, and then you've got your pod running and everything. So we've got, what, 10 minutes left. Any questions? Anyone want to see something else fun, or We can do some other bits like scaling the workload to see how many replicas we can do, or anything anyone wants to do. Oh, it's got some
I've got
questions.
yeah, I've got some questions. That in case anyone else doesn't have any, but yeah, can you roll? You know how you showed the deployments and you
Yep.
redeployed, obviously. You know the green and the green. God, I need more coffee. The blue and the gold.
Yeah.
I'm not colorblind, I swear. Can you roll back the deployment straight from the AKS cluster, or do you have to actually do that deployment again?
So you can do it from the kubectl command line. I think it's kubectl deployment rollback or something like that, and then it will roll it back. But usually you want to fail forward in this DevOps world. So I would recommend you would go fix something in your manifest file and reapply it rather than rolling something back. The only difference would be if I was doing a deployment of a software like, say, the Nginx ingress controller, and I'm using Helm, which is a package manager, to install it. So think of it like your MSI installer on steroids with your MST file, which is a Helm values file. And then I'm installing this third-party bit of software into my cluster. Then I would, and something's gone wrong with their newest release and I can't fix it, I would then roll back. But if it's something I'm in control of, I would fail forward.
And then you've got your versioning and your comments and things like that, which actually really touches on a question that's just been asked in the chat of, can we connect the service, so AKS, to Azure DevOps or GitHub and, get some CI/CD integration working?
Oh, 100%. Yeah, it's really good for that. You can even go one step further and have your DevOps agents running inside your AKS cluster, which is then controlling your AKS cluster, which is cool. I've got quite a few customers running that as well. So instead of using VMs for your DevOps agents, just have it all inside the cluster, and it's all nice and tight and secure and within that virtual network without having any peering and stuff like that. And that uses a bit of technology, again, open source, called KEDA, Kubernetes Event Driven Autoscaler. And that listens to your DevOps queues, so your pipeline queues. And if there's like one in the queue, it will run it. If there's two in the queue, it will spin up another container as a job inside Kubernetes, do what it needs to do, and then delete that job afterwards, so you're not wasting compute power. So that's really cool and powerful, and we use that a lot. I highly recommend that if you're using Azure DevOps. But taking it one step further, there's this technology called GitOps. So you can have all of your Kubernetes manifest files or Helm charts inside your Git repository. This GitOps controller lives inside your cluster, and it queries the Git repository and then configures it based on what's in your Git repository. So instead of you pushing changes to the cluster, it pulls the changes into the cluster, and then it uses your Git repository as your single source of truth. So if you change them, like in the Git repository, say I changed the color from gold to blue in the Git repository, this Git controller, which can be Flux or Argo CD or another third-party one, will query the Git repository on a set schedule and then make the changes for you. And what's really cool is if I go into the cluster and change it manually, GitOps is going to keep continuously pulling that Git repository and change the setting I may have made back. So if someone's gone in to try and fix something quickly, they need to go and do it the correct way, which is through the Git object. Otherwise, their change is going to be overwritten. So it's a way to sort of keep that governance inside your cluster as well. So you sort of stop people going in, poking around and changing things and then breaking things.
Yep.
Because it's going to fix it.
And I think you touched on a good aspect there from a security point of view as well. It's a pull, not a push. So
yeah.
It's not like you need to then have something published externally, via the firewall and blah, blah, blah. So there's definitely a good security perspective as well. The next question is really, you've kind of touched on it a bit, but it's always a hot topic. Portal or using infrastructure as code to deploy AKS. What is your recommendations here?
My recommendation is always use infrastructure as code. The options I showed you are very, 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 very small amount of the options you can actually choose. You can do so much with it now. You can even bring your own CNI, which is your container network interface, so you can bring an external one. You can, use infrastructure as code always, be it Bicep, Terraform, ARM templates, Pulumi, God knows what other ones are out there. Even if you want to go old school and use the Azure CLI, that's better than the portal. Anything
They
with the
all
portal.
they all connect to the same reset points anyway, right?
Yep.
So
Yep.
anything's better than nothing. Yeah.
Yep.
The other question is, sorry, I'm just using this as just to try and grab as much information for the audience as possible.
Yeah, no worries.
So patching, obviously, do you enable auto patching on your production clusters or not? So the documentation, the AKS documentation from Microsoft Learn indicates, yes, you should switch it on. But, for those of us who's been in IT in a while, automated patching has a state of, you do not do this in production unless it's in a controlled manner. So, yeah, what are your thoughts with this?
So if my workload can handle reboots, and I can set the schedule at a time that I can know I'm going to be available if something goes wrong, then it's fine. So like here, my Nginx deployment only has one replica. So if the cluster rebooted, or the node rebooted because of an update, which will happen, this will go away because I've only got one replica. So my app will go down. If I had multiple replicas, and this technology called pod disruption budget, which basically means I need to always have at least one copy of my app running at all times, then automate it as much as you can. Makes life so much easier. It's for the AKS updates, it's free a year, so it's not too bad. For the node imaging, it's I think I've only ever had one major issue with a node image update, and that was when Ubuntu released a dodgy update and it automatically got enabled on the nodes, and then it all
I
broke.
think I
All I had
remember
to do,
that.
yeah,
Yeah.
all we had to do was restart it, and it was fine. So, if you've got good monitoring and good applications, and they're built for cloud native, it's all fine. But I find most people don't have that yet, so that's part of my mission to get them to that point.
I guess the thing is, if you're using a technology like AKS, the design of your services should really, you should aim to have it capable of, auto restart and retries and all sorts of other things, because the underlying infrastructure can change and keep up to date. Another question is around sort of the networking and any tips that you have. So you indicated Azure CNI over Kubernetes and prod for your networking. Do you have any additional tips for troubleshooting or implementing AKS that you just want young players to avoid repeating, or that you haven't already touched on? Because you touched on a bit of really good, do not do this in production, or you shouldn't do this as part of your talk anyway, but is there anything else that
So good question. There's actually quite a few more different networking scenarios you can do for AKS, which aren't presented in the portal. So you can have the Azure CNI, which is what is in the portal, where it automatically allocates all of those IPs at default. You can have it Azure CNI dynamic mode, so it won't apply all the IPs at default only when you need them. So your network scope can be a lot smaller. And then there's Azure CNI overlay, which is like Kubernetes. It's a software-defined network, which is an overlay inside the cluster. Each node gets its own little IP range of, I think it's a /24, and then it builds its software network over everything, so that doesn't have to be the size of your VNet inside Azure. That can be smaller depending on how many nodes you're going to have. So you can have your /24, but with overlay, the overlay network can't be the same on any peered network, so it sort of has a limitation there. Then there's Azure CNI overlay with Cilium data plane, which brings this technology called eBPF, and that's probably where Azure's going to try and push everyone to at one point, because it brings so much more metrics with it. Like the eBPF goes down to the kernel level inside Linux and now Windows as well. and it brings back so many metrics for you as well. So you can then do advanced troubleshooting on all your network traffic and stuff like that, because you're doing it at such a low level. And with that technology, you can also enable this advanced monitoring for networking, which goes into your Grafana dashboard, and then it gets all of this cool metrics. So you can actually see accessing this website has a latency of this, and or we're blocking this port for some reason, and it's all going wrong. Yeah.
Okay, cool. Two more questions. One is, do you share your Oh My Posh theme and config anywhere?
It's actually on the Oh My Posh website. If you search for Pixel Robots on the theme section, it's right there.
Okay, cool. Yeah, I'll put that in the chat. And any just to finish it off, no more questions in the chat. Any learning resources that you would recommend to go step deeper for anyone who wants to dig a bit deeper in this space?
So yeah, I'm going to do a bit of self-promotion first. So I've got a course on LinkedIn Learning on AKS. It's a slightly bit out of date now because it's changed so much, but it gives you a good understanding. It's about an hour 18, so probably covered most of this already in here. If you want to go super deep on AKS, use the Microsoft Learn stuff. It's really good, and it goes into the whole cover of everything. Like you got all these nice little sandboxy bits as well, I believe. If you want to go even deeper, get on Udemy, and there's the CKA course by Code Cloud. You can also go for their website, and it goes really deep into Kubernetes, even goes deep into the control plane and your etcd database and stuff like that. So they're really good places. If you want to read and you prefer reading, there's the Kubernetes book by Nigel Poulton. He has a few different versions. You can get like a Klingon cover and stuff like that. I have a few of them on my bookshelf somewhere.
And you've got a book as well, don't you?
And I've also got a book called Azure Containers Explained, which helps. It's not just about AKS. It sort of tells you all the different options you can run containers in Azure, excluding Service Fabric because no one wants to touch Service Fabric. So it talks about functions, web apps, ACA, ACI, AKS, and basically it just gives you that sort of scenario based why you'd use one over the other, and then sort of progresses you from functions all the way up to AKS, and then has some extra bits to look into.
Okay. Thank you for donating your time. Yeah, hopefully the students and attendees have got a lot out of it. I know I did. So yeah, thank you for coming and talking to us.
No worries, anytime. But yeah, if anyone has any questions afterwards or whatever, just reach out to me online, Twitter, Facebook, email, anything, and I'll be happy to chat.
Cool. Thank you.
Cool.